wait is over. EdgeDB Cloud is here. We have a lot of ground to cover. We'll obviously talk about EdgeDB Cloud. We are releasing EdgeDB 4 today with 2 new killer features, full text search and integrated auth. And finally, we have 4 incredible guests who will share their journeys of building products and integrations with EdgeDB. Before jumping in though, how about we spend just a few minutes talking about why we're building EdgeDB? Elvis, please help me out.
Sure. We're building EdgeDB with a singular goal in mind: eliminate the friction and inefficiency that exists between databases and the rest of the stack to improve performance and productivity alike. This friction has been around for decades, to the point where we, software engineers, just assume it's an inevitable law of nature. We almost stopped asking questions like, do I have to think of my data in tables? Why are ORM libraries so complicated and slow? Why are schema migrations such a pain? Why is writing even slightly non-trivial SQL queries so laborious? And why do databases have to be these complicated monsters that people are afraid to touch? EdgeDB has clear answers to all these questions.
EdgeDB is a new database, and it features a new object data model that we call graph relational, where you think of your data as if it's a graph. That's exactly the way we think of data when we're writing TypeScript or Python code, or really any code. EdgeDB is built on top of PostgreSQL, extending its classical relational data model and replacing SQL for good measure. And that's where the magic happens, so let's talk about that. EdgeDB fully implements the concept of declarative schema. You see, many databases have schema, but it's something internal, something that is either manipulated by your ORM library or by you typing low-level DDL commands. With EdgeDB, you use our declarative schema language to describe your data and use the built-in migrations engine to do the heavy lifting. All of the tooling is completely language agnostic, meaning that the workflow is the same for a project built with TypeScript and for a project built with .NET. You learn the workflow once and you use it everywhere, across ecosystems, programming languages, and frameworks.
Laying out your application schema with EdgeDB is a breath of fresh air. Most of the concepts are self-explanatory. You have object types have properties and links to other types. Simple. But EdgeDB goes far beyond what people expect databases can do. EdgeDB supports abstract types, multiple inheritance, aka mixins, polymorphism, schema introspection, triggers, functions, dynamically computed fields, access control policies, and the list just goes on. Our schema is incredibly expressive, and this is where we are deliberately going against the trend of making databases dumb. We strongly believe that there is an enormous benefit of making your database the center of truth. With a powerful data model, you can implement your core data logic right in your database and keep the backend simple. In fact, we're going to where, in most cases, there would be no need for a separate backend service at all.
With such a powerful data model, SQL or a simplistic data access API seemed inadequate, and so we embarked on an ambitious mission to design a new general-purpose query language, one that would surpass SQL in power and expressiveness. And yes, you heard that right, and yet remain easy to learn, safe, and efficient. The result is EdgeQL. It looks like a child of SQL and GraphQL, and in a way it is. Just like SQL, it allows you to do arbitrary computation, so compute 1 + 1, or something way more involved. And just like GraphQL, it makes it easy to work with hierarchical data.
But EdgeQL is more than just a fusion of SQL and GraphQL. EdgeQL is a thoughtfully designed, strictly typed declarative data manipulation language. Its free composability makes it possible to pack multiple and potentially unrelated operations into one query. Imagine fetching all of the data your app needs to render a screen in a single, fast database request, or mutate a bunch of things at the same time without having to use an explicit transaction block. EdgeQL makes it natural and simple. EdgeQL and EdgeDB's data model are designed to work with each other. For example, our schema supports mixin types. Naturally, EdgeQL can query data by the base type. This is an insanely powerful feature that will enable engineers to design reusable database schemas and libraries around them. The other important aspect is type safety, and this is where EdgeQL also shines. For example, EdgeQL has no concept of null, improving the ergonomics of working with missing data. Every data type and standard library function is designed with care to make them foolproof.
Ellis, at this point, everybody is like, all right, all right, please finally tell us why. Why EdgeDB is so good.
Of course, I was just about to. Let's pretend you want to build a TypeScript app. You install EdgeDB with one command. That's 20 seconds. You create an EdgeDB database for your project. That's another 20 seconds. You run a couple of npm installs, another minute. Then you can generate type-safe TypeScript functions for your EdgeQL queries. Or you can run another command and use our fully type-safe query builder. The beauty of it is that it maps directly to EdgeQL, almost one-to-one. Learn one and you know the other. Never again will you need to stop using the API because it's not powerful enough or because it's too slow and writes SQL by hand.
At this point, you might be wondering, so what's the big deal? Well, the big deal is that EdgeDB is a complete solution. It's a new database with a lightning-fast installation, a data model with features no one would ever imagine in a database, and an amazing developer experience when it comes to building real products. And the cherry on top is that EdgeDB does it all without sacrificing performance. It's a lot faster than ORMs and even handwritten SQL sometimes. EdgeDB can be thousands of times faster than mainstream solutions. The funny thing is that we're only scratching the surface of what EdgeDB is and can do. For example, EdgeDB comes with a powerful graphical interface with which you can visualize the schema, or dive into the output of query performance analysis, or do data input and editing, or play with the in-browser ID, and many, many other things. Anyways, I think at this point, we should have convinced you that EdgeDB is the best thing since sliced bread. So it's time to talk about EdgeDB Cloud. Everybody knows the story of Achilles and the tortoise. It's supposed to be a thought experiment until you find yourself living through it. It's quite literally how we felt building EdgeDB Cloud. There is a myriad of things to consider and carefully implement when you are building a service that would be the foundation for other products. It feels like it will never end, but today we're proud to report that we have finally overtook the freaking cloud tortoise. EdgeDB Cloud is here, and you can start using it today.
Since we're challenging pretty much every aspect of a database stack with EdgeDB, it felt natural for us to do the same with EdgeDB Cloud. We want EdgeDB Cloud to have the best-in-class developer and DevOps experience, so we started with setting some goals. Watertight integration with our command line and client APIs, beautiful and functional UI, everything from managing the cloud instance to visualizing the schema to writing queries and editing data in your database. Secure by default, powerful data layer that's fast and eventually capable of replacing your backend entirely.
One thing that I always disliked about databases is the sheer amount of configuration you usually have to do. It's everywhere. Installing and running a database on your machine can feel somewhat awkward at times, but then connecting to it can be a whole other level of pain. With EdgeDB, we reduce configuration to almost nothing. For example, after you install the EdgeDB command line tooling, you can just use the EdgeDB project init command to create a database for the current app you are building. It could be either local or hosted in the cloud. The workflow is literally the same. After that, running a REPL, opening the graphical UI, or connecting from your code requires no configuration. EdgeDB handles everything for you, creating TLS certificates, finding the available network port, running and stopping when not used, and so forth. And naturally, we want our cloud to follow the same principles. All you need to do is to run the EdgeDB Cloud login command to authenticate with GitHub, and then you can create your cloud instances. And to make it easy to tell local instances and cloud instances apart, we are using a simple naming scheme. Instance names that are a single word are local. Instance names that are word / another word are cloud instances. Your GitHub username or organization name is what's before the slash, and your cloud instance name is what's after. Simple.
What else is simple is our client APIs, but only on the surface. Let me explain. We've put a lot of effort into designing a state-of-the-art network protocol and client libraries. The protocol is fine-tuned for speed. Most client queries need just one round trip to the server, no matter their complexity. It is a stateless protocol and can be easily tunneled through HTTP, which makes it compatible with edge environments. Additionally, the server can send a detailed query description back to the client. This includes information like whether the query changed any data and which system features were utilized. Our client libraries are designed to take full advantage of the protocol. If a network error occurs, they'll automatically reconnect to the database. If a query was in progress during the disconnect, the library will attempt to retry it, but only if it's the type of query that's safe to retry. And if a transaction serialization error pops up, the client will automatically retry the transaction. And to top it all off, our client libraries do connection pooling transparently. Just works. This is incredibly important for the modern development practices, where the backend code and the database are no longer running close to each other. What's more important is that all of this requires no user effort. Writing resilient code has never been easier.
Back to the experience of managing your EdgeDB Cloud instance. You can either use your terminal to provision and manage your cloud databases, or you can use the graphical UI, which I honestly believe is best in class. Once you create a cloud instance, you'll see the instance dashboard where you can access the metrics. We plan on shipping multiple improvements to the dashboard in the coming months, if not weeks. And of course, the built-in EdgeDB UI, like the web REPL and the data editor and the schema browser, are there for you. The UI is fully responsive and mobile-friendly. Deleting your production database on the go has never been easier. Joking aside, we believe that EdgeDB Cloud UI is the key to enabling you to ship faster. With it, you can postpone creating an admin panel for your app, prioritizing user-facing features instead.
EdgeQL is the most powerful and efficient way of interacting with EdgeDB. However, EdgeDB can also respond to GraphQL queries over HTTP. Better yet, since EdgeDB version 3.0, we have full support for PostgreSQL wire protocol, meaning that you can connect any tool that supports PostgreSQL and write analytical SQL queries against your data. All of it works via the same endpoint, and EdgeDB automatically negotiates the protocol depending on the client needs. Of course, EdgeDB Cloud supports these features at launch. So in addition to an EdgeDB database, you also get a GraphQL server and a SQL database for the price of one. The EdgeDB protocol is secure by default and requires TLS, so each EdgeDB Cloud instance gets a free trusted TLS certificate. There's no need to hassle with TLS setup.
EdgeDB Cloud is available today with a range of storage and compute options. And of course, there is a free tier option that will be available soon. EdgeDB Cloud has been the biggest request by our community. It's our pleasure to finally deliver, and we can't wait to see you using it. In other news, EdgeDB 4 is here, just a little over 4 months since the release of EdgeDB 3. And by the way, EdgeDB 3 was a hell of a release that we spent a year working on. Just to remind you, and I'm going to skip over a lot of things, with EdgeDB 3, we shipped query performance analysis, aka the analyze command, multiple updates to the UI. We practically rewrote it, adding things like a web REPL, visual query builder, and a lot more. The new EdgeDB watch command to enable rapid schema prototyping, triggers, mutation rewrites, splat, read-only SQL for your business intelligence tools, and of course, pgvector support. Because we are now shipping major versions quarterly, EdgeDB 4 isn't quite as massive. Nonetheless, it has a number of important and impactful features. Sally, can you tell us about the biggest new feature of EdgeDB 4?
Sure. The flagship new language feature in 4.0 is full text search, which, of course, we refer to using a 3-letter acronym, FTS. Let's start with a simple schema, and let's say you want to enable full text search for the item type. All you have to do this is add a special index to explicitly declare which properties of the type should be searchable. And then you can just call the FTS search function, and we'll search all these index properties. The result you get will have a list of matching objects, along with a match score for each of them, and you can use that for ordering or for filtering. And since it searches all of the index properties, it's simple to extend the search by adding multiple properties to the index. And of course, you can assign different weights to better rank your results. And on top of that, it integrates with our inheritance hierarchy. If you add additional properties to the index in a child type, searches on the parent type will search those properties as well.
All right, this seems very simple and straightforward. Fun fact, a few months back, we wanted FTS to be part of EdgeDB 3. Why did it take so much longer than it was originally planned?
Well, since we're building on top of Postgres, the most straightforward way to deliver FTS would be to just wrap Postgres' text search implementation in an EdgeQL-friendly way and call it a day. That would probably take a week or two of work, but that isn't how we try to do things. We believe that Postgres is the best database backend in the world, but obviously we think that we can make a better front end. That's why we're doing any of this at all. So all of our major features go through a design and review process, and you can see all of the history of our FTS design in its RFC on GitHub. And in particular, one of the key goals for FTS from early on was that its API should support pluggable search engines.
You mean like Elasticsearch?
Exactly. We want to be able to support cases such as starting with Postgres text search, but then transitioning to Elasticsearch as your needs evolve. Or maybe using Elastic in your staging and prod instances where it's important, but using Postgres text search in local dev instances where it will simplify setup and lower your overhead. We aren't quite to the point where we're shipping the Elastic integration, but we needed to be sure that the multi-full text search engine scenario was supported. And the only way for us to be confident that our design actually worked with both backends was to actually prototype it on both backends. So we used Elastic, and specifically the ZomboDB Postgres SQL extension, in addition to the native Postgres text search in order to test the new API.
Okay, this is very cool. So can we now call the FTS implementation complete?
Well, not quite. There are some features still missing, like highlighting and autocomplete, that are on the to-do list. Those will likely ship with EdgeDB 5 in 4 months or so, but a full Elastic backend is probably further out. But already the main text search functionality is there in EdgeDB 4, and you can start using it today. And of course, I would like to give a huge shout out to my teammates Alyash and Victor, who put a huge amount of work into the design and implementation of FTS.
This is great. I'm excited to finally see FTS implemented. It was one of the most requested things from our users. The other popular request is rather minor in comparison to FTS, but was nevertheless a prominent one. And I can't say I feel easy about it, as someone whose favorite programming language is Python. I'm talking, of course, about our if expression. We inherited our if syntax from Python, which was awkward in the beginning, but after years of use became muscle memory. But EdgeQL is now used by a lot of people, many of whom don't have a Python background. So we decided to bite the bullet and redesign if. Here's the new version. And I have to say, it's nice. It's immediately familiar and straightforward. What's not to like?
I actually have something to add about if. We now support conditional DML, which is to say insert, update, and delete inside if statements. Accomplishing this was technically already possible, using what somebody on our Discord once referred to as the dreaded for loop hack, but now it's actually convenient and nice to use. And keep in mind, EdgeQL queries are still atomic, they're still executed all at once, even with complicated cases like that. On top of this, you can now use DML in combination with the coalesce operator on the right-hand side of question, which makes expressing things like select or insert if it's missing really easy to do, even in cases that are too complex for unless conflict to handle.
In EdgeDB 4, we're adding a new scalar type, multi-range. We have had simple ranges since EdgeDB 3. For example, you can use a range of dates to represent when a musical band was active. But what if a band was broken up and then reunited? What if it happens multiple times, like the Eagles maybe? Multi-ranges to the rescue. The coolest thing about multi-ranges is not that you can store basically an array of ranges, but that you can efficiently operate on them in filters. Queries like, give me the list of bands active on this particular day are easy to express and will be run efficiently.
Another exciting development 4.0 is mostly just under the hood right now, and that's our changes to our parser, which is quite a beast with over 1,900 syntax productions, including its schema definition language and the data definition language used for writing migrations. Previously, the EdgeQL parser was written in Python using the parsing library, which, fun fact, was originally developed by Jason Evans, the creator of the famous JEmalloc memory allocator. And we've managed to push this Python parser pretty far. It has decent performance, and we implemented nice error reporting on top of it. But its time was always limited, and it's now coming to an end as we prepare to implement the language server protocol. Implementing LSP requires a new type of parser that can consume broken and incomplete output and still give a partial parse in order to support things like code completion in an IDE. On top of that, we also wanted a parser that would be easy to embed in our CLI or even our web UI. And that meant something, unfortunately, not written in Python. So in EdgeDB 4, we moved to a hybrid parser system. We're still using that Python parsing library to declare our grammar and to build our AST, but we've rewritten the core of the parser in Rust and implemented an error recovery algorithm for it, based on what the popular treesetter library does. So far, the main outcome of this is we've managed to reduce the baseline server memory consumption by 40% and even sped it up a little bit. And this means in the future, we'll be able to build tools on top of the new parser, like language server protocol and new things embedded in the CLI and UI.
EdgeDB 4 has a number of other improvements. For example, we added the BeatGig crypto APIs and a number of new standard library functions. That said, there is another huge new feature of EdgeDB 4 that deserves its own in-depth segment. In my opinion, it's one of the biggest features of this release, and it's important for both EdgeDB and EdgeDB Cloud. Time to talk about the biggest feature of EdgeDB 4. Allow me to take a step back for a second. Why are we building EdgeDB again? To remove friction. And what causes an enormous amount of friction during development? Always ends up pretty fragile and breaks at the most inconvenient moment. Is it React Router? Maybe Webpack? It must be Python packaging. No, it's the auth. Authentication is simple in principle and yet incredibly annoying to implement, test, and support. And it's one of the things you literally need to build first for pretty much any product. I bet many ideas never materialized because engineers just couldn't find mental energy to deal with auth. Today, we're putting an end to this, and Scott is here to tell us more.
Hi there. You're right, Yuri. Starting any new project takes a lot of activation energy already. You have to think about what makes your idea unique, decide on how to assemble your tech stack, and prioritize the most important features to quickly validate your ideas. The last thing most of us want to do is to solve the authentication puzzle again. When was the last time you did it? How are you going to integrate authentication data into your data model this time? Since you've chosen EdgeDB, you already know that our focus is making a robust and productive solution for building the next generation of great digital products. And building authentication into EdgeDB is our way of clearing the road for you to focus on what matters most. In EdgeDB 4, we're delivering a comprehensive native built-in auth extension. Enable it by dropping using extension auth in your schema and applying the migration. With the UI or an EdgeQL script, you can easily configure the auth extension, such as if you want to use the email password flow, or if you want to use some of the social identity providers that we support in EdgeDB 4, such as GitHub, Apple, Google, Microsoft. Big thanks to Sully for all the recent hard work making our extension configuration system flexible enough for such a powerful and complex extension.
All right, this is cool. So is this all I have to do to enable this in my app?
Well, almost. You then need to make the decision whether you want to use the built-in UI or build your own.
Wait, you said built-in UI?
Yeah. EdgeDB Auth comes with a hosted authentication UI that you can link to from your app. Big shout out to James for all the hard work getting this UI looking so polished on this and the configuration UI. No matter what language or framework you use, if you don't want to bother with implementing login and related pages, you can just use the built-in login UI or implement your own, your choice. The UI supports logging in with our available social identity providers, as well as email password login flow that comes complete with password recovery and email verification. And if you want to implement your own UI, you can do that too. The auth extension has a few documented REST endpoints that you can use from your application to completely customize the look and feel of the authentication to match your design. You can even start with our hosted UI solution and later switch to your own. And we'll provide auth packages to complement popular backend web frameworks such as Next.js and FastAPI to make integration with your app dead simple and completely turnkey.
Right. The UI is just one part of the equation here. There's a lot of other auth-related complexity that EdgeDB just knows how to handle, right?
Exactly. One challenge of a separate authentication service is securely passing the sensitive authentication token back to the application through the web browser. EdgeDB implements proof key of code exchange flow, called PKCE, to securely verify that your security-sensitive data does not accidentally get leaked in the insecure browser environment. PKCE was first introduced to solve authentication security for mobile apps, but has quickly become the standard for exchanging sensitive data, even in high-trust environments. And you only need to implement a couple of trivial endpoints in your backend. One with a one-liner to initiate the PKCE flow, and one or two endpoints to handle signed in and just signed up users. Our forthcoming web frameworks helper libraries will help make this part as painless as possible. Once EdgeDB completes the authentication flow, either with a social identity provider or with email and password, it generates an authentication token. This token is a JSON web token that EdgeDB knows how to verify and handle. In short, the auth extension exposes a client token global variable that you need to set with your EdgeDB client library. We've defined another global called client token identity that is automatically computed from the authentication token, which you can use to define access policies right in your schema or access directly with your EdgeQL queries.
So what if I want to define my own user type with things like settings and preferences?
Well, that's easy. Our auth extension defines a type called identity. And thanks to the ease of linking objects in EdgeDB, you can define your own user type and add a link to the extension's identity object. When a new user is registered via email or some social identity provider, a new identity is created and the user is redirected back to your application. There you can create a new user and link it to the freshly created identity. Ultimately, you have full control here, and you can implement whatever additional logic you want.
This is awesome. And how would email-related things work?
Well, thanks to our teammate Fantix, you can configure the extension to use a standard SMTP server that EdgeDB uses to send emails for verification or password recovery. Obviously, it'll be pre-configured for immediate use in EdgeDB Cloud, but it's handy to set up a custom SMTP config when you develop locally or if you want to deploy EdgeDB yourself.
Beautiful. So what's next for us?
There's a lot of things that are going to be shipping right after EdgeDB 4 and in future major versions of EdgeDB. For example, like we mentioned earlier, we are currently working on creating libraries for popular web application frameworks like Next.js, FastAPI, and others to make auth integration as easy as possible. Next, hopefully in one of the point releases in the 4x line, we'll ship a new UI to browse through user identities, as well as user-defined types that link to identity objects. Our goal is to evolve the built-in UI to the point where it can fully replace the need for a dedicated admin panel for your app. Another important feature related to authentication is auditing. We have some ideas on how to seamlessly integrate auditing right into the extension itself. We're already hard at work to introduce a number of other OAuth providers, such as LinkedIn, GitLab, Discord, Slack, Facebook, many others. We're also working on enabling integration with Okta and Auth0, as well as accepting third-party tokens to help integrating into existing or enterprise authentication systems. At some point, we want EdgeDB Auth to natively support things like two-factor authentication, magic links, and new standards like WebAuthn, which would allow usage of the latest security features like passkeys. We want our authentication extension to become an all-encompassing solution to solve authentication once and for all for any size or type of product.
Thanks, Scott. This is extremely impressive. The future of EdgeDB Auth is bright. Now let's hear from one of our users, Jack, co-founder of Credal.ai, on how they accelerated their development in TypeScript by building on the foundation of EdgeDB.
Hi, everyone. I'm Jack, the co-founder of Credal.ai, and we're excited to share how we get the most out of EdgeDB to accelerate making AI work in the real world. First, a bit about who we are. Credal helps organizations use their internal data with AI to reap the huge productivity benefits that AI promises while protecting sensitive information. We take care of things like mirroring permissions from data source systems, audit logging, and private data redaction to give IT and security teams what they need while letting users and developers inside of organizations get the most out of AI to do things like analyze data and create experts and tools that can accelerate their entire organization. We're backed by some really cool investors like Y Combinator and OpenAI's previous head of product, Fraser Kelton, and we can count several billion-dollar companies as customers. So how did we get to EdgeDB? Well, when I built applications in the past, I remained floored by the amount of boilerplate and wiring involved, the unworkability of ORMs, and how much attention was drawn just to making things work together and away from the point of whatever you're building. Now, for web apps specifically, the world of TypeScript and React have come really far for type safety and developer productivity. But working with data persistence is still surprisingly error-prone and time-consuming, and tools like ORMs often seem to make it worse and not better. When I saw EdgeDB on Hacker News in 2019, I finally knew I wasn't crazy and that this was by far the most promising option I'd come across. So we at Credal are building in enterprise AI, and this is actually one of the fastest moving and competitive areas in software right now. Industries like this could be thought of as following an evolutionary process, where there's strong selective pressure for certain characteristics. So for our giraffes here, the selective pressure is on the length of your neck. But for us, I would actually suggest that it's the speed of iteration. So for us, developer productivity and the ability to correctly get your ideas into bits is actually a matter of life and death for us. So when we founded Credal, I knew we should give EdgeDB a try. Today, we'll touch on two important iteration speed benefits we gain from EdgeDB. One is enforcing type safety across our entire app, And the second is how we take advantage of EdgeDB access policies to move fast and be less error prone. So first, type safety. It's the kind of thing that should be easy in 2023, but between all of the boundaries in a typical web app, schema to query, to server code, to API serialization, to network, to React component tree, there are actually a lot of places for this to go wrong, and a surprising number of things you have to configure properly and massage to get right to actually reap the benefits that you want. So how do we do this with EdgeDB? Well, like many web apps, we run on Next.js, and we also use a tool called tRPC, that's TypeScript RPC, to generate React hooks for our endpoints, including the inferred input and output types of the API code. Then in front-end code, we just use the hooks, and they have certain types, and the networking is abstracted. So this is nice, but it gets really cool when you consider that the API code is making EdgeDB queries, and thanks to the native EdgeDB TypeScript client, we get type inference off of those queries, and then those types are used to infer the input and output types on the endpoint. That means that changes from a migration in the schema or a change to a query are immediately reflected everywhere, even in that random bit of UI code that you forgot about. Let's take a look at a realistic example. So suppose we have a data model for chat conversations. We have a conversation object type and a messages object type, and the messages are attached to conversations. So say we'd like to rejigger this a little. We used to store the username on the conversation type, but maybe now we want to have multiple participants in the conversation, so we want to move it down to the message type where it can vary by message. Now, luckily, as a side note, EdgeDB actually makes a migration like this very easy. We can add the property and backfill it by traversing the link to the conversation and pulling in the old username. But after we've run our migration, the queries that pull in conversation data now have different shapes, and that affects the return types of the relevant API endpoints, and that affects the types of the data used in the component, and boom, EdgeDB has immediately let us find the exact places that are broken as a result of this change, and suddenly we see the errors statically in our component code. So once you're at this stage, you can make the relevant fixes here in your sleep, and indeed sometimes we do. Now let's talk a bit about permissions and access policies. These happen to be an important part of our offering at Credal, but really they're an important part of any business application. Unfortunately, even the best developers are human and can make mistakes. When dealing with sensitive data, mistakes don't just harm our business, but can cause negative, serious consequences in the real world. So on top of all the best practices, the answer here is really to minimize the surface area of places developers even have the opportunity to introduce mistakes or need to remember to check certain things. And at Credal, of course, we accomplish this using EdgeDB access policies. We encode our logic for RBAC, certain discretionary controls, data permissions from the source systems that we touch, and of course, multi-tenancy into EdgeDB access policies. This means that for 90% of work, the developer doesn't have to worry about access controls and permissions. We can still safely work on most code in a low-stakes way, even when we're tired or not doing meticulous reviews, and centralize the really important logic and any evolution of that logic in one place, which is our EdgeDB schema. Here's an example API endpoint, again using tRPC. In our code that initializes API requests, and we do things like parse the user's token, we also create an EdgeDB client object specifically for the user, and this is what the developer receives in their API code. From there, the developer can write EdgeDB queries and access policies just work. Even if we write a bad query, or in some extreme case where logic is exposed in the wrong way or to the wrong user, the safety net of EdgeDB kicks in, and we simply get a runtime error instead of a data leak. Of course, in certain places, we want to run operations without access policies, such as to edit certain permissioning data. And for this, we actually run a custom ESLint rule that finds and makes us document each of the uses of EdgeDB clients that have access policies disabled, so that we can be especially mindful of those queries. So stepping back a bit, certainly other databases do support access policies in different forms. But as we evolve our product and our data model gets more complicated and features have different interlocking permissions, the convenience, reliability, and readability of layering those systems on top of the graph relational model means we can easily go way beyond what most people normally use schema-level access policies for, like a safety net for maintaining multi-tenancy, if they use them at all. Again, in the limit, iteration speed is what matters. It's been awesome to use tools that were designed to work together and shrink the surface area of what developers have to think about when they go about their daily work. We get both productivity and safety improvements from EdgeDB. It's often rare that those two variables move together, but EdgeDB's design and tooling get us there. Check us out at Credal.ai. We're hiring, and thank you.
Jack is right. Iteration speed is very important. Now, let's hear from Jeremy, CTO of BeatGig, to learn about their new Python GraphQL framework that will be another massive level up for EdgeDB users building GraphQL APIs.
Hi, I'm Jeremy Berman, and I'm the co-founder and CTO at BeatGig. BeatGig is a marketplace for booking musical artists. You can think of it like Airbnb for live music. We power thousands of shows a month, anywhere from your local bar in New York City to a large corporate event. We're growing quickly, processing millions of dollars of bookings per month. We have a website and an app, but we don't have an engineering team. In fact, it's just me and my co-founder building the entire product. And today, I'm going to share with you a bit of how we do it. But we are looking for our first few engineering hires, so please DM me on Twitter if you're interested. Before founding BeatGig, my co-founder and I were in the Y Combinator Winter 19 batch, which we went to after college. And I do all of the back-end engineering, and my co-founder does all the front-end engineering. So as the only back-end engineer on many projects since 2019, I've gone through a ton of iterations in how I like to build servers. I think many of you will be able to relate to my journey. And it usually starts with a simple REST endpoint. This is it. It's the simple REST endpoint which just returns a booking. It has an artist ID and a venue ID, and the front end, if they want the artist and the venue, can query separately. So you get the booking, and then if the front end wants the artist, you can query based on the artist ID, and if the front end wants the venue, query based on the venue ID. It's great for the back end because it's really simple. I just return a booking. But it's slow for the front end, and it creates what's called the N+1 problem, which is you get the booking, but then there's a +1. You need to get the artist, and then after you get the artist, maybe you need to get the artist, the payment information for the artist, and you keep on going and going. And this means that what's simple for the back end ends up being slow for the front end. And in a chart, fast for the front end to simple for the back end, this is in the bottom right corner. So the next iteration you might consider is just including the nested objects in the response to begin with. Something like get booking will return a booking with artist and venue. This requires fewer front-end requests per screen, maybe even one if the screen is not complicated, because the front end no longer has to query separately for the artist and venue. It's given it. But this is more complicated for the backend. The backend now has to deal with small artist objects, small venue objects. I'm sure you also might sometimes want the artist profile picture or the owner names of the venue. Objects, and then you need to add auth to these objects. You end up having a ton of specific objects floating around, and you end up over or underfetching in certain cases. It's not ideal, but it's faster for the front end, and for that trade-off, it's less simple for the back end, but it's fine. And then there's the third iteration, which is something like bookings dashboard response, which means that the back end is building endpoints specifically per query. This solves the N+1 problem and is as efficient as it gets, right? You have a bookings dashboard screen. There's an endpoint for that, and the endpoint queries the database in the perfectly efficient way possible because you already know what the query is going to be. You already know what you're going to return. So this is fastest for the front end, but this ends up being complicated for the back end, right? Every single new screen requires a new back end endpoint. But of course, you can mix and match these, and we have and do. Each one has their strengths and weaknesses and should be used in certain cases. But the builder in me always wondered, is it possible for you to build a simple backend where you just define types and define how they relate that is also fast for the front end? So this is where my journey with GraphQL started. This is kind of the promise of GraphQL, at least for the backend, which is you just define your types and then you define how they relate to each other. And then the front end gets to query that like a graph, right? You build the graph of your schema and the front end queries that. No more the front end saying, hey, can you add this field to the bookings with venue query? It's all there. And so this N+1 problem is actually solved for the front end. And it's really simple for the back end. The problem is the N+1 problem is now moved to the back end. Because the way it works is on the back end now. Oh, the front end wants a booking. And then, the front end also wants the artist and the venue on that booking. The way that works is the back end gets the booking, and then it says, front end also needs the artist, let's get the artist. And then front end also needs the venue, let's get the venue. So now we've just shifted the N+1 problem. So I would put this simple for the back end relatively. You define your types, and then you define how they relate, right? Build functions to resolve. So on a booking, I want to resolve an artist. But For the front end, you haven't really gained that much speed. Sure, you've reduced latency between the client and server, but the server to backend latency is still something to consider. So the question is, can the backend solve this n+1 problem? Which would really mean, can the backend dynamically construct database queries based on the front end's dynamic query? Well, with normal SQL, that seems pretty difficult, and you can see why that isn't the default with GraphQL. Because SQL returns flat objects, and it's hard to query nested objects, right? You have to joins, and you get back a flat object. How do you unfurl that necessarily into your complicated structure you want? But if we were to be able to do it, what we would need is an easy way to query and filter nested objects, and then also for the database to return those objects as JSON, right? As nested JSON, as objects that we would reason about. So this is where EdgeDB joins the picture. We found a way to elegantly build dynamic queries with each request with EdgeDB. This is because we query EdgeDB like a graph instead of a flat structure. There are no joins, and we build isolated queries per node and stitch it all together at the end. So just to run through it, the front end creates a request, and then for each node and property that the front end wants are instructions on how to update the EdgeQL query, how to update that specific node. We construct the EdgeQL query dynamically at runtime, and then we execute the query. And then we also tell the server how to unfurl that query into the response. And so the result looks something like this, where the front end requests a booking with an artist and a venue, and then we construct a large EdgeQL query with all of the fields that are necessary to resolve the response, and then we unfurl that into our schema. This is a simplistic example, obviously, where the front end request maps to generally the EdgeQL fields, which generally map to the backend response. But at BeatGig, we've been able to build this to very complicated queries that resemble almost, the front end request resembles almost nothing like the back end, and I'd be happy to dive into that a bit deeper if you DM me or maybe in a blog post. So, I've gotten very excited about EdgeDB and the prospect of finally creating a server that's fast and easy to build. And for this reason, I got to work trying to build, a framework, a GraphQL framework that actually integrated with EdgeDB really well. But what I found with the existing GraphQL frameworks in Python is they just didn't have the flexibility or the simplicity that I needed. I was looking for a fast API for GraphQL. And so eventually we just built it. It's called FastGraphQL, FastGQL, and we're open sourcing it basically today. You can find it at jerbear//fastgql. We're already using it on many of our screens at BeatGig, and it's really, really fast and really simple. All you have to do is define your pedantic models, define how they relate, and then using our query builder, queries are constructed dynamically, and it even has dependency injections. So finally, with FastGQL, we've been able to create a simple framework for the backend that executes super fast code, so the front end can create arbitrarily long, requests to the backend, and we can fulfill those very simply with just one request. It's really great. We've been loving it. And here's just a taste of how simple it is. This is the booking by ID call that we've seen earlier. It returns a booking node. But this booking request could be super complicated. It could have the artist and then all of the artist's managers and then all of the bookings that manager's ever been a part of. It could return all of that with just this code, all constructing a simple EdgeQL query, a large EdgeQL query, and executing. So we're really excited about this. We love FastGQL. We hope you guys do too. Thank you very much.
FastGQL looks incredible, and we can't wait to play with it. Next, we have Gabriel, who is building a spiritually similar thing, but with ReScript.
Hey everyone, my name is Gabriel, and I work on the ReScript language, where I contribute to the language itself and also the ecosystem around it. I also work at Arison, which is an IT consultancy in Stockholm, Sweden. We combine traditional consulting with building new businesses through the incubator we're part of. And most of these businesses are bootstrapped, meaning like we don't raise that much external capital. We try and do as much as possible with the little we have. And in order to do that, we need tools that are fast to work with, that can kind of take a beating. All of you who's ever built something from scratch knows that Building from scratch means you're going to shoot yourself in the foot. We like to say, like, when you're shooting yourself in the foot, use a small gun and aim for the soft parts of the foot so that the damage is kind of minimal. And we're trying to take that mindset and translate that into our tech choices. So we need safe and scalable tech that's fast to work with and fast to build with, and that can take us changing things often and much. So refactoring shouldn't be a problem in the tech choices we make. And we believe that ReScript and EdgeDB fits this really well. So today I'm going to talk a little bit about both ReScript and EdgeDB, of course, but also how you can use them together and what the benefits of doing that might be. So first off, a little bit about ReScript. The tagline for ReScript is fast, simple, fully typed JavaScript from the future. It's a language that obviously compiles to JavaScript, so it's available for usage anywhere where JavaScript runs, which nowadays is most places. It's also like small and simple, but very powerful. I like to think of it as being a toolbox with quite few tools, but they are really, really sharp. It's built on 20 plus years of academia, and it's fully focused on building real things. So it's not a toy or a research language. It's deeply focused on the practicalities of building and scaling software. So ReScript has a strong sound and practical type system, and sound here means that it's 100% safe, as in if it compiles, it's going to work. It has a compiler that's kind of more your helpful friend than someone you report to, which other compilers can feel like, where you need to constantly convince it that this thing I'm doing here that you're seeing, it's actually what I'm planning to do. It also compiles to JavaScript that's often faster than handwritten JavaScript. And you can use it alongside or instead of your regular JavaScript or TypeScript code. In fact, ReScript focuses on interoperability with JavaScript, like both code and the ecosystem. So if you wanted to, after this talk, you could probably ship ReScript code to production in your existing TypeScript code base in 30 minutes or so. It's really easy to get started and integrate with the things you already have. So, a little bit about ReScript, now a little bit about EdgeDB and why I find it so interesting. I love Postgres, and I've been using Postgres for a really long time. Postgres has, as you all know, a lot of very powerful features. And I think most of them are, the powerful features are pretty hard to use without a lot of friction. And this is like partly Postgres, partly just the fact that databases are stateful and pretty like hard to deal with once they're in production. It's also hard to get the tooling really good around Postgres because SQL has such a huge and ambiguous kind of syntax surface, which makes it hard to build robust tooling for it. So here's a number of things I need in my day-to-day from a database in order for things to kind of move smoothly. Migrations, of course. I need to be able to evolve my database over time. Row-level security is one of my absolute favorite concepts in all of this. The ability to have authorization as close as possible to the data that drives it is just fantastic. Triggers, obviously, mutation updates, relations, and being able to reuse table layouts and properties, as in, I know all of my tables needs timestamps, and I want those timestamps to always be updated whenever I update the table. Computed fields, being able to keep computations that are possible to do in the database, so that I don't have to ship additional data to the backend or whatever just to process it there, when I could just do it in the database instead. So Postgres is kind of great at some of those things, and some of them it can't really do in a good way. But unless you're a Postgres expert, it's usually kind of hard and full of foot guns, and not the nice kind of small guns I was talking about before, more like a shotgun which kind of blows away the entire foot rather than just makes a nice little hole. And I think that EdgeDB fixes this and a bunch of other issues I've had with building things and using databases. So we've kind of established that EdgeDB is our solution. How do we use it with ReScript? Well, we've built an integration between ReScript and EdgeDB that lets you write EdgeQL directly in your ReScript code. So if we look to the code at the code here to our right, you'll see that ReScript looks very much like JavaScript. It has let bindings, async await, arrow functions, and everything. But also notice that there's not a single type annotation thanks to ReScript's fantastic type inference. But all of this is 100% typed and fully type safe. So what happens here is that the tooling picks up your EdgeQL and generates types from it. It uses the official standard EdgeDB JavaScript tooling, so it's tweaked to ReScript, of course, but it's kind of future-proofed because of that. And ReScript will wire the generated types up with the EdgeQL thing you've written inside of ReScript with no manual plumbing needed. So you never have to import any type annotations and assign them to the query you've written and those things. Those things just work. And also notice that it's just EdgeQL. It's not an ORM or a query builder. And we're betting on staying as close as possible to the actual source, which is EdgeQL in this matter. So I also have a bonus thing that I would like to show you, which is kind of cool. And it really shows how you can combine ReScript's type system and with EdgeDB and get something really productive out of it. So do you know how much you overfetch from your database? Do you know how much in your application you select from the database and then never ever end up using? It's really hard to keep queries clean and free from unused selections, obviously, because adding selections is really easy. You just add them and then they're there. Excellent, you use them, perfect. Removing them, though, is kind of hard because you need type generation for all of the queries you write, or the type system won't help you. You need a sound type system, or the type system can't help you as much anyway because it can't track all of the places where you're moving with your data and if things are being used or not. And even with all of this in place and all of this working, you still have to remember to kind of do it, to go through and remove a field, see if it compiles, remove another field, see if it compiles, and so on. And all of this leads to accidental overfetching, and that really adds up over time and slows down your application. So imagine you fetching things in your query like that it's expensive to compute, and you fetch that, and then you don't use that data anymore, like you remove the code that actually used the data. If that stays in your query, you're going to fetch that from the database every time, and these things will add up and slow down your app and slow down the performance of it. So can we solve this with ReScript's type system? Turns out we can. The EdgeDB ReScript integration ships with a CLI, and this CLI can look through your entire project and find any unused selection in any of your queries. So if we look at the example output now to the right here, we can see that it runs on your entire project, and it finds that in file movies, in query all movies, for instance, there's inside of the actor selection, there's a selection called number of pets, and that's never used. There's also a title selection directly on the query that's never used, and so on. So all of this is possible because of ReScript's type system, and because ReScript as a language is small and simple. So doing this type of fairly advanced statistical analysis at compile time is, I wouldn't say easy, but still like it's possible to do in a sane way. It also includes a CI mode, the CLI, so you can run this on in your CI and make sure that you break CI if you have selections that you're not actually using. So you can prevent overfetching from ever reaching production, essentially. And in the future, we think we could have the CLI automatically remove the selections as well, so that all of this becomes a process of just running a command that kind of cleans up your entire code base for you. Maybe even have editor highlighting for the fields that are unused. So you could see directly in the editor that this field here isn't used anywhere in your actual code. So as for the future, what excites me going forward? I really think EdgeDB is looking fantastic already. I'm really excited for it. And I believe EdgeDB will continue to deliver like good solutions to common problems of using databases. And I'm particularly excited about editor tooling and the other tooling that's emerging around EdgeDB. So I personally really like thinking about bridging the gap between languages and database and application and so on. So imagine you could seamlessly move between your ReScript code into your EdgeQL code and get completions and have code actions, refactors, and everything that you could run on the EdgeQL code and have it reflected in the ReScript code, for instance. So kind of moving towards the, what I call like the GraphQL editor experience, that when you set it up properly is really, really good. So that's some other things that really excite me for the future. So that's all from me. Thank you very much for having me.
I must say that ReScript integration is impressive and looks quite solid. Kudos, Gabriel. Next, we have Marcus, co-founder of Dexa.ai.
Hi, my name is Marcus, and I'm here to talk about how Dexa is using EdgeDB to build its data layer. So before I get started there, talking about the what's and how's, I would like to talk a little bit about myself. I'm originally from Brazil, and I moved to California 15 years ago and been working in tech companies for those past 15 years. But more specifically, in the last 10 years, I was both at Stripe and Docker, building large-scale infrastructure and developer tools that are used by developers and customers every day. At Docker, two of the projects that I was involved was building Docker Hub and then adding support for Kubernetes in Docker. That led me to Stripe, where I built its container platform and help build the framework that Stripe was using to migrate from its big Ruby monolith to a more service-oriented architecture. And I think the experience of working those two companies highlight the two things I really care about, that is reliability and scalability of the platforms that I'm working at, plus the developer productivity aspects and expressiveness, right? Being able to use those tools to build meaningful products and experience to customers and users. So that led me to Dexa, and Dexa is a new way to search for content. We like to call like a research engine. And with Dexa, you can ask questions and get answers from experts and people you trust, right? If you listen to, we're starting with podcasters, and there's this huge wealth of information being produced every day in the form of podcasts with a lot of like world-class experts talking about different subjects. And Dexa allow you to ask questions and get answers from that source with citations and tracking back to where that was said. And so we have that provenance associated with the content. And our V0 is now live at Dexa.ai, and you can use to get answers from questions that you might have. So why EdgeDB at Dexa? So my co-founder had great experience with EdgeDB 2.0, building a different project. So when he decided to start Dexa, he decided EdgeDB was a great fit for what we're trying to do. And so far, we have scaled to over 4 million objects, and we're storing 4 gigabytes of data in our data store. And that's critical and the central part of our ingestion and inference workflow. So here's an simplified overview of how Dexa is structured. Dexa can think about like 3 main services. We have the app that is where we serve our users, but kind of critical for us is that how we add new content, and that content is all stored in EdgeDB. So EdgeDB for us is both the data plane and the control plane, because for the admin, we control what data needs to be added to our systems, and the ingestion pipeline is able to pull EdgeDB, get the information, and download the content, transcribe content, is stored back to EdgeDB, because EdgeDB is our data source of record for all the data in our systems, including embeddings. And from there, we can create the index that we store in our VectorDB to be used by the app at inference time in our serving pipeline. And that's how we get answers back to users and being able to reference back to what their content came from. So why EdgeDB? I think the kind of one of the killer features for us is its TypeScript support. Well, Dexa is written in TypeScript. The majority of the code in Dexa is all in TypeScript, and EdgeDB allowed us to write idiomatic and reusable TypeScript code. We have like a type of model type package that centralize all the interactions that we have with EdgeDB, and the combination of types in EdgeDB plus TypeScript just give us the high level confidence that our code's correct. The refactors are much safer because we know exactly what's expected. And we mainly use the query builder for that. The query builder has been a great productivity booster for us because we're able to express complex SQL queries in a very easy, idiomatic way. Most of our queries are written using query builder, And it's very easy for us if we need to debug something to be able to call to EdgeQL and get the actual EdgeQL query to make sure the things are looking correct and express like 99 of our use case. But it's also great to know that we have escape hatch, and CodeGen for us is that escape hatch. Or there are times that we need to express a more complex query, and in that case, we write EdgeQL query that we use CodeGen to generate the final code that we use. And we use that in a couple of places when we have to write embeddings that have more complex arrays, data types, and things like that require if statements or for loops that we can do all in EdgeQL in a single transaction. Other piece that's very critical for us is links and backlinks. We think the data model in Dexa as like a kind of knowledge graph. So we have a core that is like people. People for us is our core data piece, and where we have all the relationships between like, who were present in the podcast, were the episodes, like who are the guests, who are the hosts. And EdgeDB uses of links and backlinks abstract a lot of the complexity they usually deal with in the relational database around many-to-many tables, one-to-many foreign keys. Being able to just express as links and backlinks is much closer to the data that we're trying to model. But we don't lose the kind of normalization benefits that you have from a relational database. So for us, that's been a great tool. And kind of related to that is like this ORM-like power that we get from EdgeDB. We talk about backlinks, but in general, it just gives us a very expressive data access layer without a lot of the trade-offs that we get from ORM. We heavily use computed and default properties as a way to move critical logic away from the application, right? Like for example, a very common way for us is to do like how many guests are in the show and how to define what should be the default value. They're not just like simple properties, can be things more complicated than that. And more recently, we have been using triggers and mutations as a way to simplify some like very complex tasks, or not necessarily complex, but repetitive, right? Like how to keep track of an updated field, like when the last modification was done, or having a trigger that sets like a constraint of the system that's not just like a table like a traditional index would be able to express. And additionally, as we're thinking about like expansion of Dexa, having the ORM not written in the core language allow us to introduce a new language like Python with minimal effort, keeping a lot of the kind of business logic that was defined in our schema is still relevant. And with that, also the approach of having the kind of almost like to think about an out-of-process ORM makes much easier for us to monitor and centralize our operations of the cluster, right? We have EdgeDB as a great tool to debug and analyze query performance. One of the things that we do is like just being able to go to EdgeDB and use analyze to look at a query. So here's an example of how we would like analyze the performance of a query, right? We just append analyze at the beginning of the query, and EdgeDB gives us the cost and where we're spending time, where the links are being calculated, how many loops are going through, and that just like is great level of visibility and understanding what's going on under the hood. And building like a platform on top of EdgeDB, being able, like we haven't had any kind of major incidents or any incidents so far, knock on wood, operating EdgeDB on the cloud. And because we can just use a lot of the tools provided by the cloud provider to manage Postgres, we have access to tools like snapshot and replication and all the suite of monitoring that give a lot of, we have this great pane of glass that gives us understanding what's going on in our systems. So to recap why Dexa plus EdgeDB has been a great fit for us, we're able to iterate and build products much faster than we would if we were not using ORM, if we're just having to write a lot of just raw SQL. The combination of TypeScript and EdgeDB is just a more productive overall framework, and we still have the trust that the data is safe by relying a lot on the kind of great track record of Postgres of scalability and reliability. That's it. All right. And if you're interested in hearing more about Dexa, check out our careers page as well. Thank you.
All right, it's time to wrap up. Jeremy, Jack, Gabriel, Marcus, a big personal thank you for sharing your stories. Thank you all for being with us today. We hope you'll enjoy EdgeDB 4 and EdgeDB Cloud. Join us on Discord for a live Q&A, and we'll see you again in 4 months for the EdgeDB 5 launch. Thank you.